Hello, testing, testing. Bam. Hello, good morning, or afternoon, evening, wherever you are. Hi, Pembu. Hello. Welcome to the stream. Yo. I'm actually kind of excited today, and also a bit nervous. So, in case you can't tell from the title of the YouTube stream, I wrote. Ready for some epic bash? Heck yes. Yeah, I wrote a piece of bash software that crashes my computer if I can't solve a Leetcode question in a specific amount of time. Like, no joke, it actually crashes my computer. I'm running on WSL, which is like simulated Linux on Windows. So this is the line PowerShell /C, the command shutdown. So you guys probably won't see it on stream when it happens, but my computer will literally blue screen immediately without prompting me for a password and shut down. Yeah. Should I explain how this code works? It actually auto-detects if I solved a Leetcode question. Let's see. Pembu, it's the shutdown command. I was hoping for a fork bomb. What is a fork bomb? I don't know what that is. Let's see. Yeah, someone made a Leetcode API on GitHub, so I forked the repo, I downloaded it. I had to manually set the, what did I change? Yeah, their cache was like 5 minutes or something. I had to set it to 2 seconds so that it would actually, you know, if I solved the question in the last 5 minutes, it would actually detect it, you know? I learned it the hard way. Dude, my computer crashed so much during testing, or shut down, inexplicably. First it was when I was hitting 0 seconds, it wasn't detecting that I solved it. And then I found out that it only changes every 5 minutes. The answer that it gives, because of the cache. And then there was some rate limiting stuff I had to change too. But yeah, it works. The script auto detects if I've solved a Leetcode question, and if I haven't in a specified amount of time, shuts down the computer. Embu says, a fork bomb is a command that spawns an exponential number of processes, using up all your resources and hang your system. Wait, that sounds even more exciting. Might try that in the future. Spawn an exponential number of processes. Holy. Oh, hi Z. Hello. I'm just showing the bash code I wrote for shutting down. Okay, you guys ready? You guys ready for some leak coding? Okay, before we do that, let's select the question, yeah? I've been going down the blind 75 list. We were on search and rotated sorted array, sorted array, the binary search question that gave me a headache in the charity stream. I looked at these two problems, 3-sum and container with most water. These are all medium questions. I think I want to start off with an easy question, you know, to guarantee that we at least do one question during the stream, right? So I was like, okay, what about climbing stairs? No, we don't do binary. So yeah, let's do climbing stairs, which I've solved in the past with Java, but not in Python before. Okay. So back to VS Code. Okay, let me make my text bigger. Can y'all see if it's like this? Okay, so how the script works is that I can run the script called timer.sh. It will prompt me for the number of time that I will set to solve the problem, you know, before the computer crashes. So I will do, how long should we do for this? 30 minutes? Maybe 30 minutes for the first one, and then we can decrement it by like 5 minutes for every subsequent one. Sure, let's do 30 minutes for the first one. Oh, can I make this even bigger? Sure. All right. You ready, guys? It's actually gonna start when I press enter. Bam. Oh. Okay. We're off. Oh, let me make this smaller. Oh. Shizzle. I'm already feeling the pressure. Oh. Okay. Climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. And how many distinct ways you can climb to the top? People asking questions. I have a question. Do you learn DSA first and then do questions later, or learn for each question? Oh, I actually already knew some DSA before practicing. I did learn some DSA while Leetcoding though. Maybe you can learn while Leetcoding, like learn exactly what you need for each scenario. Okay, each time you can either climb 1 or 2 steps, and how many distinct ways can you climb to the top? Define climb stairs self-hand. Okay, this is a recursion problem, right? How in the world? If we have 0 steps, then we've already reached the top, right? So that's 1 way. That's our base case, right? If n is equal to 0, return 1, and else, time to do some recursion. So we can climb the stairs. You can either climb 1 or 2 steps, right? 1 or 2 steps. So how do recursive calls work in Python? Can I just call like the function like here? Do I have to include self? Maybe n-1 to simulate climbing the stairs in 1 step. So like return climb stairs n-1 plus the result of climbing stairs n-2. Do the blind 75 while doing it, you'll be learning Rishab. Oh, possibly. Okay, is this really it? What if n is equal to like a really negative number? If n is less than 0, then return 0, then no solution. Okay, let's try this. I believe climb stairs is not defined. Oh, wait. Python. Recursion. Is that not how you do recursive calls? Try recursion. Do I have to do self, maybe? Self. Oh, shizzle. Wait, why? Uh-oh. Is this not how you do Python recursion? Global name climb stairs is not defined. Why? Do I need a helper function? Oh, wait. Python recursion climb stairs is not defined. People are attempting to climb stairs too. What is this? Define climb stairs. Self. Oh, self.climb stairs. Is it self.climb stairs? Self.climb stairs. I guess that makes sense if it's a self call. Oh. Self.climb stairs. Run. Please. Oh! Oh, hi Yosuke. Yosuke says, hi Chet. Did Chet autocorrect to Cherry? Okay, we're gonna submit this, but I feel like it's gonna fail. We're gonna have to do some memorization, right? We're gonna get a time limit exceeded thing. And then we're gonna figure out memorization in Python. Oh boy. Time limit exceeded, yes, I thought so. Do the more optimal solution. What is the more optimal solution? Okay. We're gonna have to do some memorization here. Holy. Let's call this helper, yeah? Helper. For the actual climb stairs, we're gonna call the helper. Self.helper, maybe? N. Sure, let's just see if this runs first. Chat, can you suggest me C++ course? I don't really know any C++. Or I have taken C++, but I don't have recommendations off the top of your head. Top of my head. Run. Wrong answer. My output was null. Is it because I didn't return anything? Return self.helper. Nice, okay. So now we can turn helper into a, helper function. And we can input we can memorize stuff. Like save our progress from previous recursive calls. So let's call this the cache over here. Official Satori says, I made a new edit on TikTok since it's not banned. Oh yeah, TikTok. TikTok got unbanned, right? By President Trump. That was pretty crazy. I have 22 minutes left before the computer crashes. Code Defense says, use a hash map to cache. Yeah, hash map, which is like a dictionary in Python, right? Cache is equal to this. So we'll pass in this cache into the helper function. And then in the beginning, maybe after all these base cases, right? We'll do if we've seen a cache hit. So if what? N is in cache, is that how you do a key hit? N in cache, then return cache N. Hold on. How do you tell if the key is in a cache? I mean, a dictionary. Python. How to tell if key in dixt. The in operator. I think that's what I did. Yeah. Okay, we got it. Yosuke says, yep, so I made a new account yesterday. Wait, you deleted an account because you thought it was getting banned? Oh, that's kind of sad. Did all your old content go away? Okay, I have 21 minutes until computer crash. I think I should be fine. First problem, we should get through one problem. Hopefully. Knock on wood, knock on wood. Okay. We need to cache our solution at the end. So result is equal to this whole chunk over here. The recursive call. Then we need to return the result. Too many lines. And then we'll cache the result after we compute it. Cache result. No, cache N is equal to the result. I think that's it. Let's run this. Oh. Oh. Helper takes exactly 3 arguments, 2 are given. We need to input the cache, don't we? We forgot to update it with the new params. Man, it keeps throwing me off by the 3 arguments thing. I keep forgetting that self is like indirectly passed in Python. Let's go. We have 19 minutes before computer crash. Wait, is there a way to tell that the cache is actually getting hit? If n in cache. Let's print. Chat. Cache hit. Oh, I don't think the cache. Oh, cache is getting hit. That's awesome. Cache getting hit. What would you even do for the cache hit 3? Cache hit, comma, n. Kuroiso said, I believe in you. Oh, thank you, man. What would be the cache hit for 3? 1? Does that even make sense? Wait, should we get more cache hits? So 3 we would do, you can take 1 step, so 2. Wait. My brain. It can't process this for 3. For 3, we would break it down into recursive calls of 2. If you take 1 step, and then 1 if you take 2 steps. You would go down this path first, right? I think that's how it works. You would take 1 step, which gives you 1. And then from here you take 1 step, which gives you 0. And then you would return. And then you would get 0 here too, which would stop over here, but not hit the cache. If you take 2 steps for 3, it's 1. Yeah, so you get a cache hit for 1. Shouldn't you get another cache hit over here? For 1? Or is it my imagination? Okay. We have 17 minutes until computer crash. Let me just submit this. I feel like we should have more cache hits, but I'm not sure. Let's go! Okay. Hold on. My program is still running. Hey! It worked! It worked, guys! I was getting worried I went detective for a second. Leetcode problem solved? True. Congratulations. Crash countdown stopped. Code event says you can do it more optimally. You can. I'm actually curious about the more optimal solution. Are you talking about dynamic programming? Thank you. Thanks, guys, for the applause. We're gonna do one more with even stricter time constraints. I want to see what... Oh my goodness. What the frick? If n is less than... What am I looking at? This solution. Oh, 1 space. Yes, this is still DP. Okay, so here, I'm looking at other people's solutions now. If n is less than 3, return n. Oh, he pre-calculated. If n is less than 3, then the answer is n. Okay, I guess he just calculated that and observed it, I guess. A is equal to 3, b is equal to 2. I have no clue what he's doing here. I'm guessing he pre-calculated. Wait, what? I'm guessing these are like the base cases, right? maybe 2 and 1. I don't know. Yeah, I have no clue what he's doing here. Why are people doing Fibonacci here? This solution is confusing. D is equal to dictionary, okay. Define fib n. If n is less than equal to 2, return n. Okay, I'm guessing that's just the base case. If n is in D, yeah, that's the cache hit. dn is equal to, that's the, yeah, take 1 step, take 2 steps. Yeah. I noticed they don't have to do the self dot stuff. That is a bit cleaner. You just need the last 2 previous. Oh, you just need the last 2 previous. Do you? Is that true? This guy is storing everything too. No, I feel like... Do you? Is that true? Because what if... Surely multiple paths lead to n is equal to 1, right? Or n is equal to some small number. His solution is not optimal either? Really? Okay. I'm also realizing I could have kept it, I didn't have to do the self dot function stuff. I could have nested my function definition here, so it could have made my life easier. Define helper. So I could have nested helper in here, right? Define helper like this. Python's gonna complain about indenting, so I'll indent these. Wait, what happened here? Return, oh, okay. Yeah. So instead of, I can just do helper, I think. I don't need to do the self notation. Hopefully that's how you do it. Let's run this. Yeah, nice. Okay, cool. Hey, we solved one problem. That was intense. We had 17 minutes left to spare though, so it wasn't that bad. Are you guys ready for the next problem? Threesome? This is a medium problem now. Oh, Code with Ven sent me something. Wait, let me see what's your solution. Okay, just gonna remove all this. What is this? If n is less than 3, return n. Last 1, comma last 2 is equal to 1, comma 1. For I in range. Oh, you're good, you're good. I think the chat just naturally formats it this way. Okay. What is this? If n is less than 3, return n. Okay, I guess that's from pure observation. Last 1, last 2 is equal to 1, 1. For I in range, n minus 1. Temp is equal to last 1 equal last 1 plus last 2. Oh, wait. Oh. I think I know what you're doing. It's you're kind of doing bottom-up dynamic programming, aren't you? But, so, this is n. If n is like, I don't know, 1, 2, 3, 4, I pet the deal? and then the result. So you're doing the first two solutions are 1, 1, and then for I in range n minus 1, temp is equal to last. So you're basically adding, this is 2, is it? Wait, actually I'm kind of lost. What are you doing here? N is less than or equal to 3, return n. This is 2, this is 3. Okay, what happens if n is... What happens if n is 4? For I in range 3, so you're doing 0, 1, 2. So if n is 4, you're doing range 3. You can rename last two to previous. Last two is previous, and last one to current. Okay. Okay, that makes sense, I guess. 1, 1. Temp is equal to last one. So it's 1. Okay. Then the previous is 2. Last 2 is equal to temp. Oh wait, so you are starting from the beginning. Okay. I think I see what you're doing. Oh. 1 plus... Wait. 1 plus 2, 3. So it's basically just adding the previous 2. This would be 5. Alright. Huh. Cool. I don't think I would have thought of this on the spot. Okay, thanks for sharing. Okay, are you guys ready for threesome? How much time should we do for this? 25 minutes? Let's do 25 minutes. Oh wait, it's literally a Fibonacci sequence. Okay, how much time should we allot to solve this one? 25? For threesome? Sure, I'll do 25 minutes for threesome. Let's decrease the time by 5. 25. Okay, you ready, guys? Bam. Oh, it's on, it's on. Oh, shizzle. Threesome. Given an integer array nums, return all the triplets nums I, nums j, nums k, such that I is not equal to j, I is not equal to k, j is not equal to k. So basically their indices are different, and nums I plus nums j plus nums k is equals to 0. Okay. Oh. So basically return all the 3 unique, not unique, like separate, but yeah, unique, may not contain duplicate triplets. So return all unique triplets of numbers that add to 0. Okay, I have a vague memory how to do this, which is good. Let's look at an example. -1, this sequence. So -1, -1, and 2. Contain... Wait, hold on. -1 and -1 are repeating. -1, -1, 2. The set must not contain duplicate triplets. Oh, it's the triplets that can't be duplicates. The indices just have to not be the same. Okay. Ooh. How? I have a really vague memory of how to solve this, which I'm starting to question. I have 23 minutes until computer crash. Oh. Let's zoom in here. Wouldn't it help us a lot if we sorted this? That's what my memory is telling me. So this turns into -4, -1, -1, 0, 1, 2. Okay. It's almost like a glorified brute force that we're doing after sorting. We would start like one pointer here, like I is here, and then we will look at every single J following this. Or we can do like, okay. I think it's a good thing that I remember, I vaguely remember what the solution is. JK. We can sort of do a hack, like a greedy algorithm. So for every single I, we instantiate J and K at the end here. And since everything is already sorted, if our if our sum is greater than 0, that means we have to decrement K. So we move K down like this. Yeah, because everything is sorted from in ascending order. So if we want to make our sum smaller, then we decrement to a smaller number, which is guaranteed to be on our left. And that is the next smallest number. So we decrement the sum in the smallest possible way incrementally. And then if the sum of the three numbers is smaller than 0, then we increment J with the same reasoning. Okay. Yeah. We're gonna have to watch out for duplicates too, right? We can't do duplicate triplets. I have 21 minutes until computer crash shizzle. So every time I increment 1, every time I decrement J, I'm gonna have to watch out for triplets. I mean duplicates. Ho. Ho ho. And when do you increment I? When J and K cross over with each other, then there's probably no solution at that point. Yeah, so for every single I, you make J and K closer to each other until they converge. And then increment I, start over J and K on both sides, bring them closer until they converge. And that's how it's almost like you're doing n squared time. Yeah, for every single I, you look at each number only once. Okay, I think that's a plan. It's way easier said than done though. Oh my goodness. So let's do for I in range 0, the lane of nums minus, I have to make space for J and K at the end, right? So 2. So I should iterate through the start 2 until the third to last number. Oh. Should I just do a sanity check now? Make sure I'm doing it right. Print I. Oh ho ho. Print nums I. I should only be iterating through the third to last number. All the way to 2. Yeah, that's correct. Let's instantiate J. J is equal to I plus 1, and K is equal to the end index, len nums minus 1. Oh. Ho ho. While J is less than K, I have 18 minutes until computer crash. While J is less than K, well, right out the bat, if the sum of everything is 0, then we're good to go, right? If nums I plus nums J plus nums K is equals to 0, then return all the triplets such that. So I need to return a list of triplets. Okay. My result is equal to, I'll instantiate that into an empty list then. Oh, this is gonna get kind of messy. And then if I see a solution, I'll append it. Is that how it works in Python? Do I append to list? Python list append. Yeah, it's append. Okay. Copy this. I. Is this how you do it in Python? That append. Maybe I have to wrap all this in a list too. Oh, I just realized my syntax is kind of off. Okay, that should do it, I think. Is there a base case I can test this with? 0, 1, 1, 0, 0, 0. Oh, this one might be right after I do this. Should we do another sanity check? I think it'll be useful. K plus equals 1, K minus equals 1. And then we'll return just as a bogus value result. Result. So hopefully this should solve the last one, if my base case is right. Hey, nice. Okay, we're on the right track then. I have no idea how this one is passing. 0, 1, 1. I'll put nothing. Okay. Oh, okay, we're on the right track somehow. You forgot to sort? Oh, I did forget to sort. Thanks for telling me. How do you sort in Python? Nums.sort? Let's print out nums. Run. That is BS. I refuse to accept this is okay. Now I need I need some test cases that don't pass under my stupid solution. Yep, nice. Yeah, let's use a test case. Huh. Interesting. Okay. 14 minutes until stream crash. Am I sorting right? 0, 1, 1. Yeah, okay, I'm sorting it right now. Nice. Okay. Okay, we need to worry about what happens if, let's say, we need to track what the sum is. Let's do sum is equal to this whole shtick. Sum is equal to 0, then return the answer or append it. Okay, if sum is less than 0, that means you need to increase your j plus equals 1. How do you do else if in Python? Python else if elif. I guess I'll do an elif. J plus equals 1. Okay. Elif sum is greater than 0. You probably don't need this check at this point, but I'll do it just to be clear. Minus equals 1. Alright. Let's run this. 13 minutes left until computer crash. Uh-oh. No, why? J... I mean, if sum is equal to 0, then we don't do anything, right? What if we do J++? I see, we're probably getting stuck here, right? Can we confirm that? And stuck here. Run. Because that's the only explanation. Yeah, stuck here. Yeah, okay. We need to move on somehow from here. J plus equals 1, perhaps? And then we need to watch out for duplicates too. So while nums j is equal to nums j minus 1, like it's equal to the previous, then you keep incrementing j plus j. So that way you prevent duplicates. Yeah. Is that what we should be doing? 11 minutes left. Very crazy. While we need to make sure we're inbounds too. While j plus 1. Oh shizzle. If j plus 1 is less than len nums, if it's inbounds, and I am currently equal to my previous, then j plus equals 1. That makes sense to me. Oh. No, why? Okay. Or, why isn't it or? Is it actually an or? Run. No, it's not an or. Okay, it's fine. We have 9 minutes left until stream crash. No. Why are we missing this last one? What's going on here? Ooh. We have -1, 0, 1. -1, 0, 1. That's really early. -1, 0, 1. Why? Why are we outputting that? Is it a really beginning check? Append nums I, nums j, nums k. What? How in the world are we getting that? Oh wait, it's a duplicate. It's a duplicate. -101. Where? What? -101. What? I don't get it. Oh wait, we have two -1s. The x is duplicating. So every time we increment I... Oh... Oh my goodness. Every time we increment I, we have to make sure it's not a duplicate from its previous either. So, If we have 8 more minutes until computer crash. Less than, if I is greater than 0, meaning we're not on the first one, we've actually started incrementing. And, oh no. We need to make sure it's inbounds too. Oh, shizzle. And it's inbounds? And, oh, frick. My brain. So we need to make sure it's inbounds. And if it's... Is this a while I is greater than 0? And I is less than, let's just do len of nums. So that guarantees us inbounds. And the previous I, nums, I, the current I, is equal to nums I minus 1, the previous one. Then you increment your I plus equals 1. What about I plus 1? If I is greater than 0, and the next one would be inbounds 2. And the me is equal to my previous. Then I plus equals 1. Len, we have 5 minutes until stream crash. Oh shizzle. Is this actually gonna work? Please. No! Nums. Okay, I don't even know what's wrong at this point. How do I even know? This is blasphemy. How do I debug this? No. Use test case. Bruh, how do I even debug this? What? No, I have 4 minutes left. Wait, how do I debug this? I is greater than 0. I will recommend implementing a two-sum function and then looping over it in 4 minutes. In 4 minutes. I is plus 1 is less than... Uh-oh. Yes, you got it. Should I put this at the end instead? Well, so we don't need this anymore because we're guaranteed to increment it. Well, I plus 1 is less than... What about a minus 2 here? We have 3 minutes left until computer crash. No. That's for sure. Yeah, I'll try this one. Can we add this test case? Do we already add it? Use test case. We don't need that. We don't need that. Wait, actually, we might have needed those. No. Two minutes until stream crash. Yeah, I don't know what the frick is wrong with this, guys. Why? What could be wrong? And I realized I just deleted all my useful test cases in the beginning, which I should have needed. Well, looks like this is the end, guys. The inner while loop should be global. I have no clue what that means. The inner while loop. Inner while loop should be global. Wait, what does that mean? J plus 1 is less than len nums. The other outer while loop should be removed. What? The other outer while loop should be removed. Wait, I don't get it. What? The inner while loop should come. The inner while loop should come after all the if statements. I have 1 more minute until stream crash. Are you sure about that? I'll try this. Well, I guess this is the end, guys. I can't even tell what's wrong here, man. How would I even debug? Remove while loop at the bottom. Relax this. 17 seconds. Okay. Well, it was a good run, guys. 11 seconds. Control C. No, I will not Control C. I will stand by my program. Hey, 1 hour stream is pretty good for my standards. Oh.